Hello, we are. This is the lab for the power plant engineering. Our first practical is about introduction to the thermal power plant and its layout. So we will start with that. So in case of the thermal power plant, as you all know, it's a huge source of electricity for us. In India, majority power, almost 65 to 70% power is being produced by the thermal power plant itself. There are also non-conventional energy sources like solar energy and wind energy also. Biogas plants, OTEC is there, but they are not sufficient enough to serve the needs of India at this stage. So still we are more relying upon the thermal power plant, which are the large producer of electricity in terms of the thousands of megawatt energy to meet our requirement, right? So first of all, let's talk about the power plant engineering laboratory. In the case of the power plant engineering laboratory, you need not to write anything except the quiz and assignments given to you, right? Except the assignments and quiz given to you. So we will be uploading all these practicals time to time in practical session hours, and thereafter you will have to take the printout, and at the end of semester you might have to submit that along with the quiz and the assignments given to you as a part of your practical work, right? So you did not to write any practical work. You have to just give answers to this simple quiz and the assignments. That's it. Okay. Anybody is there? Hello. I think somebody has joined this meeting.
Yes, sir.
Yes. So you can listen to me.
Okay, sir.
Uh, huh. I am just sharing some videos of the introduction to the thermal power plant and its layout, how it is working. So uh, let's go through it. Yeah. Please be with us. So as you are all aware that thermal power plant is the large source of electricity for us nowadays also. Uh, some network issue is there. I am just solving that. So I think everybody is familiar with Microsoft Team.
Yes, sir. Some just started, so maybe they are trying.
Okay, let's wait for 5 minutes and then after we will start. Meeting has been already started. So let's wait for 5 minutes more. And at that time, I am also joining with some videos also. So that will be easy to understand for you to how your thermal power plant works. Okay.
Okay, sir.
Let's wait for 5 minutes more. At that time, during that time, I will set this screen for you. Students, are you there?
Yes, sir.
You are the only student.
Yes, sir.
Okay, let's wait. So we are starting. Uh, See, our first practical is to study about the modern steam power plants, or you can say modern thermal power plants. See, as introduction, I say that the almost two-thirds of electricity requirement of is pulled by the thermal plant in today also. In this power station, steam is produced by burning some of the fossil fuels, uh, majority of coal, and then it is used to run a steam turbine. In the steam turbine, heat energy is converted into the mechanical energy, which is used for the generation of electric power. And generator is an electromagnetic device which makes the power available in the form of the electrical energy. Right. Uh, so. If you try to visualize the layout of the thermal power plant, that is our basic motive, or you can say basic aim of this today's practical. That is, it consists of the four main circuits. That is named as the coal and ash circuit, air and fuel flue gas circuit, and circuit and the cooling water circuit. Right. So these are the four basic circuits of the thermal power plant. I am repeating, that is coal and ash circuit, air and flue gas circuit, water and steam circuit, and cooling water circuit. So first of all, we are starting with the coal and ash circuit. See, coal and ash circuit, these circuits deal with the mainly feeding the uh, boiler with the coal for the combustion purpose and taking care of the ash that is generated during the combustion process, and includes the uh, equipment that is used to handle the transfer and storage of the coal and ash. See, this is the simplest circuit uh, as far as this thermal power plant is concerned. Coal and ash circuit, it is very short. First of all, you are feeding the coal in the boiler for the combustion purpose. There it is burnt, and this chemical energy is into say heat energy, and with the help of that, this water is converted into the steam, and thereafter product of combustion, that is the remaining product of combustion is ash, that you have to say dispose, that is the coal and ash circuit. Second circuit is air and second circuit is air and flue gas circuit, right? So we know that air is the main components in the firing of the objects, or you can say coal, right? So in this case, uh, 1 minute. So we know that the air is the one of the main components of the fire triangle, and hence it is very compulsory or necessary for the combustion. See, we have to burn lot of coal. Uh, so in high pressure boilers, so lots of coal is to be burnt inside the boiler, and it needs a sufficient quantity of air, which is supplied using the either forced draft or induced draft fan. What is your, as per your, you can say the arrangement that you have made for the say supply of air. See, in the case of the say high pressure boilers, or you can say the boilers they are using in the thermal modern thermal power plant, basically require for air for the combustion purpose, right? So you cannot go for the natural draft. If you remember the say draft system, that means natural draft, due to the natural pressure balance, you cannot make the air to flow inside the entire circuit. There has to be some mechanical draft. So you have to provide the fan also. Either it may be your 1 minute. I am just entering in the team again. Okay. Wait for 1 minute. રેકોર્ડિંગ ચાલુ છે રેકોર્ડિંગ કર્યું છે એટલે આજ સ્ટાર્ટ થવા વાર થઈ એટલે મેં મોબાઈલમાં ટીમ ચાલુ કરી દીધું એટલે પછી હવે આમાં ચાલુ થવામાં તો બહુ વાર લાગે છે હા okay, so we were on the say draft, or you can say the supply of air. So we can use the either post draft or induced draft fans. The exhaust, एक मिनट भाई आवाज ओछो करो ने लेक्चर चालू. See, we require lots of air for this, so you can use either the forced draft fan or induced draft fan for the through, right? That is required. Right. So what is the basic air and gas circuit? That you are supplying the air for the combustion of the coal, and again that air is a carrier of heat for you, for water to get it converted into the steam, and also after the combustion the product of the say gases, or you can say product of combustion, will mix with the air, and that is known as the flue gas, and that flue gas is passing the through the entire circuit of the say boiler plant, or you can say thermal power plant. Like, first of all it will pass through the boiler, then it pass through the say superheater, then economizer, air preheater, etc., right? And then through the chimney it is exhausted. That is basically air and gas circuit. Now water and gas circuit. In case of the water and steam circuit, this section deals with the supplying of steam generated from the boiler to turbine, and or steam from the turbine by cooling it from to form water in the condenser, so that it can be reused in the boiler, plus making good any loss due to the evaporation, etc. Right. So what does it mean? First of all, see, it's a closed cycle for us generally. When you supply the water to the system in the boiler, then by supplying heat it is converted into the steam. That steam is passed through the boiler, right? That steam is passed through the steam generator, and it is expanded, and the boiler is due to that the boiler rotates, and that pressure energy and kinetic energy is converted into the mechanical work, right? And that steam is exhausted to the condenser, where it is condensed, and again it is get converted into water, so that we can get again that steam in form of the water to again feed it into the boiler through the feed pump, right? So that is the 1 minute, please. ડોક્ટર આમાંથી આપણે કેલેન્ડરમાં ક્લિક કરીને ક્લિક કરીને જવાનું છે ને આર્યો રાઈટ આમાં હું જોઈન કરી દઉં આમાંથી બોલતો ફરી 1 minute. I am joining the meeting through the desktop. Please hold the 1 minute. Yeah, are you getting my voice?
It's echoing, sir.
You are the only student?
No, sir. I and Tejas are there.
Only two?
Yes, sir.
Okay. Then also the dev will continue. Please hold for 1 minute. Basically, I want to show you some videos regarding, say, basic layout of the thermal power plant. So you will find it somewhat interesting. Please hold on. Can you listen to the sound? Hello, students?
Yes, no, sound not coming.
Okay. Okay. Let me try once again. I think there is no sound. I think there is no sound coming. Students?
No, sir.
Okay. Uh, please hold on for 1 minute.
આઈ થિંક સર જ્યાં ટીમ શેર કર્યું ને સ્ક્રીન શેર કર્યું ત્યાં જ આનો ઓપ્શન હશે સાઉન્ડનો.
1 મિનિટ પ્લીઝ, કેમ કે આમાં શું છે ઘણી વાર ક્રોમ જે છે ને એમાંથી એક ઓપ્શન આપણે સિલેક્ટ કરવાનું હોય છે. માઇક્રોફોન એલાઉ. ઓકે. ક્રોમમાં સોરી ટીમમાં
ટીમમાં સ્ક્રીન શેર ચાલુ કરશો ત્યાં જ ઓપ્શન હશે.
સ્ક્રીન શેર તો છે એમાં.
એ
Okay.
સ્ક્રીન શેર ચાલુ નહીં કર્યો હોય ને, હવે
હા,
સ્ક્રીન
અત્યારે
શેર
ચાલુ
કરશો
નથી.
ત્યારે હા, હવે ચાલુ કરશો ત્યારે જ ઓપ્શનમાં આવશે શેર ઓડિયો એન્ડ
Share.
વિડિયો. ઓડિયો એન્ડ વિડિયો.
ઓકે, આમાં નીચે I can't see options over here. એક જ મિનિટ, આપણે બીજો ટ્રાય કરી જોઈએ. Let's try to run with the help of VLC Media Player. Let's see whether it will work or not. Okay, there also sound is not coming. Okay, please wait for a while. I will just come back to you.
સર શેર ડેસ્કટોપ લખેલું છે ને ત્યાં ઉપર ઇન્ક્લુડ સિસ્ટમ ઓડિયો લખેલું છે.
આમાં થશે આમાં ડબલ જોઈએ
શેમાં
હવે જઈશ
અંદર ટીમમાં
સર શેર ડેસ્કટોપ લખેલો છે, ત્યાં નીચે ઓપ્શન લખેલો છે ઇન્ક્લુડ સિસ્ટમ ઓડિયો.
એક જ મિનિટ કઈ જગ્યાએ છે
આ શેર ડેસ્કટોપ છે ને એના નીચે શેર ડેસ્કટોપ પર ક્લિક કરો સર.
કઈ જગ્યાએ છે લોકેશન
મોર એક્શન ની સાઈડમાં માઇક્રોફોન નો ઓપ્શન છે એની સાઈડમાં એક્ઝેક્ટ ડાઉન એરો છે ત્યાં બસ ઉપર
આમાં મોર એક્શન
ના મોર એક્શન ની સાઈડમાં લેફ્ટ સાઈડમાં
સ્ટોપ શેરિંગ છે ને
સ્ટોપ શેરિંગ
સ્ટોપ શેરિંગ એ સર સ્ટોપ શેરિંગ કરો અને પછી ફરીથી એમાં કરો તો એમાં નીચે ઇન્ક્લુડ સિસ્ટમ ઓડિયો લખેલો હશે
હવે શેર
ડેસ્કટોપ એમાં એ ક્લિક કરશો એટલે નીચે ઇન્ક્લુડ સિસ્ટમ ઓડિયો લખેલું આવશે.
હું શેર કરું તો આવી જાય
શેર ડેસ્કટોપ આ રહ્યું
ઇન્ક્લુડ સિસ્ટમ
એમાં
ઓડિયો
એટલે એના પર ક્લિક કરું
હા એને ક્લિક કરી દો. હવે સર વિડીયો ચાલુ કરો થઈ જશે કદાચ.
આમાં તો
સર વિડીયો ચાલુ કરો અવાજ આવશે કદાચ.
અંદર જાવ તો ચેક
આમાં
ચેક અંદર જાવ હજુ નથી ગઈ સર આખી બિલ
થઈ જાય સર આનાથી
ગઈ
સ્ટીલ વોલ્યુમ ઇઝ નોટ અવાજ નથી વિડીયો નો અવાજ આમાં કેમ નથી આવતો
વિડિયો તમે શેર કર્યો ને
એક
કેમ શેર
મેં વિડીયો કોમ્પ્યુટર
તો એમાં છે નીચે ઓપ્શન આવે ત્યાં શેર કરો ત્યાં ઇનપુટ
પણ એવું આવ્યું નહીં સર
નીચે આવે છે કરો એ નહીં તમે
આને બંધ કરી દઉં પેલા
હા
ઓકે
શેર કરો
શેર
जो इंक्लूड सिस्टम ऑन है
अच्छा ओके ऊपर चेक बॉक्स है नीचे बोलता ओके स्टूडेंट बेचारा कहता था मन then also I can't see ભાઈ લેબ ચાલુ છે કઈ ના કરવા તો આ સારું છે હા અવાજ નથી આવતો હા અવાજ નથી આવતો કે પછી ક્રોમ માં ખોલીએ
આ તો રીલ્સ માં આવે છે નેક્સ્ટ વીક ની એક દિવસ તો નહીં
sharing
બાકી ખરેખર ઓપ્શન એ જ છે વોલ્યુમ એટલે
આમાં આવતું નથી ક્રોમ માં પણ નહીં હેલો
हेलो
यस सर
હા માં ભાઈ અવાજ આપતો નથી હવે
સર
કારણ
ક્રોમમાં ચેક કરી લો ને ક્રોમમાં ચેક કરો ને યુટ્યુબ એટલે યુટ્યુબ ચાલુ કરીને ચેક કરો ને
શેમાં
યુટ્યુબ ચાલુ કરીને ચેક કરો ને કે અવાજનો પ્રોબ્લેમ છે કે નહીં
અવાજ તો આવે
હા સર કમ્પ્લીટ છે એ વિડીયોમાં જ અવાજ નથી વિડીયોમાં જ અવાજ નહીં હોય સર
આ વિડીયોમાં હતો મ્યુઝિક યસ્ટરડે વોઝ ધેર કઈ વાત ચલો આપણે એમને યુટ્યુબમાં જોઈ લઈએ આઈ થિંક યુ વિલ બી એબલ ટુ અન્ડરસ્ટેન્ડ
યસ સર
See, this is the basic layout.
See, this is the basic layout of this thermal power plant. Am I audible?
યસ સર
Ah,
યસ
this is the
Yes,
layout
sir.
of the
Yes, sir.
thermal power plant. This is the animation of that. See, first of all, see this portion. You can see this is the turbine and this is the generator. This is the overall layout of the thermal power plant. You can say that this is the cooling tower. That is the part of the cooling circuit. This is generator, which produces power for us. That means mechanical energy is converted into the electrical energy with the help of this generator. It is connected with the turbine. See, you can say this is the LP and HP turbine connected on the same shaft with the generator that induces the power. HP and LP turbines. High pressure, high temperature. Steam is entering where it is expanded in the turbine and the power is generated through it. Okay, you can see the number of stages. It's a multi-stage. You can see the shape of the blade also. This is the aerofoil shape. Okay. That is the HP turbine. This is IP turbine. That means intermediate pressure turbine, and that is LP turbine. Okay. Where the steam is expanded, and in turn you will get the say energy. This is the basic mechanism. Steam which is entering in the high pressure high turbine and exiting from that turbine that is entering in LP-HP turbine. Okay. Then okay, that steam after expansion it is entering in the condenser where the latent heat exchange will take place, and there the steam is converted into the water with the help of this cooling water, right? So it's a basically condenser heat exchanger. The cooling water will pass across that, and that cooling water in turn that will be getting heated, and that steam is converted into the water, and that water is supplied to the boiler again with the help of the say feed water pump. Okay, and that water that is heated that is supplied to the cooling tower, right? So water is supplied to the water tube boiler. That is basically, in our case, that's a high pressure boiler. So you can see these are all the burners, and heat is added to the boiler, tubes, water tubes, and that will be converted into the steam. You can see the path of the say flue gases over here also. See, basically, you can see this blue that indicates the water. See, water is coming down and it is going up there, right? After heating, and that is converted into the steam. Say, this steam drum contains two portions. 1 minute. You can see this. Okay, that steam drum. See, in lower portion of the steam drum, water is there, and that is passed through the water tubes. And during heating, that is converted into the steam, and that steam is collected in the steam drum at the top of that, and that is taken out from there. Okay. See, this is very basic thing that you have already learned in elements of mechanical engineering, right? And high pressure, high temperature, steam is entering in the turbine where it is expanded. This is basically thermodynamic cycle that you can understand from this. That is the Rankine cycle, right? These are the some data available with us. It is showing over there. That is the variation of the pressure and temperature. See, superheating is there. So superheater you can see in the figure. Now it can be shown over there. Yeah, superheater. Steam is passing through this superheater, and it is converted, dry saturated steam is converted into the superheated steam by these exhaust gases first. And that superheated steam is entering in the high pressure turbine, HP turbine. See, you can see the temperature limits, that is 600 degrees Celsius, that you are letting the maximum temperature that you are letting the steam to come in. In this case, that is 550 degrees Celsius, and after expansion, that will be converted. That will be cooled up to 350 degrees Celsius. See, this is the mechanism of say O2, CO2, etc. That we at this stage we don't require. Deaerator is there to remove the air and say dissolved gases from the water, to prevent it from the corrosive effect of the oxygen and other gases. Condenser from see, you can see this figure. See, cold water that is coming over here, and it passed through this condenser, then steam is condensed over here, and that steam is condensed and converted into the water, and in turn that the cold water is converted into the hot water, and that water is coming out, and that will go to the cooling tower, and again it will cool to the say almost at atmospheric conditions. You can see these large cooling towers. This is natural cooling tower. Here you can say the baffles are there, and it spray will come out of this. Atomization of the water will take place, and the spray will come out, and from the bottom of those cooling tower, you can see this. See, from this bottom of this cooling tower, air will go up. See, natural pressure difference due to the height. This is a natural draft cooling tower, so height is more. And here at the top of the cooling tower, pressure is less, and here the atmospheric pressure is high. So naturally, air will try to move up from the bottom to the top. And in turn, it will absorb the heat of this, and your water is getting cooled, and it will come down, and hot air will go up, and it will be go in the atmosphere with the help of this cooling tower. Okay, again, see, L and see, we were talking about coal and S circuit, flue gases, air and flue gases circuit. after heating of this, all the say walls and say air preheater, economizer, superheater, etc., these flue gases they have to be exhausted in the atmosphere. So these flue gases will enter in the this ESP, electrostatic precipitator. See, what is the need of electrostatic precipitator? Because this flue gases that contains ash particles with it. Okay, so they are harmful to the human health, hazardous. So they have to be absorbed, or they have to be stopped, or they must be prevented from going in the atmosphere, and that work is be carried out by the ESP, that is electrostatic precipitator, right? The mechanism that you will understand later on, but there's flue gases, they are required to be passed through this ESP, and it efficiency of this ESP is 99.9%. So you can see the from the figure, fly ash is being collected by the electrostatic precipitator, and then that all the flue gases, they are exhausted in the atmosphere. See, these are flue gases, but these are air. See, please make a difference. This is cooling tower, and what is coming out of the cooling tower is the moist air. But from here, these are chimneys. Flue gases, cleaner flue gases are coming out from this chimney. Okay. One more video is there that I would like to show you.
Plant Miller is a coal-fueled power
Is it
plant.
audible now?
Yes, sir.
આનો અવાજ આવે છે ને?
હા હા.
Located in Alabama on the Locust Fork branch of the Black Warrior River, about 25 miles northwest of Birmingham. The plant provides over 20% of Alabama Power Company's generating capacity and is the largest generating facility in the state, with a peaking capacity of over 2.9 million kilowatts, or 2,900 megawatts of electricity that can serve over 822,000 homes. Named for Mr. James H. Miller, a former president of Georgia Power Company and senior vice president of Alabama Power, Plant Miller first provided electricity to our customers in 1978, with the most recent unit commissioned in 1991, making Plant Miller the newest coal-fueled power plant in Alabama. At Plant Miller, we use coal, air, and water in an energy conversion process that allows us to deliver electrical power to homes and businesses. Using coal as a fuel source, we generate steam in our boilers. That steam will be used to turn a turbine that ultimately allows us to generate electricity. Of course, there's a lot more to it than that, so let's take a look at how the process works. Our process uses Powder River Basin coal from Wyoming, a subbituminous type coal, as a fuel source. When the coal arrives at our plant by train, we use a trencher and a series of long conveyors to stack coal in our yard, move it to storage silos, or send it directly to the plant. We try to keep a 37-day supply of coal, about 1.4 million tons, on the pile in our coal yard, and up to 40,000 tons in silos. Since we burn as much as 38,000 tons of coal in a 24-hour period, we need to ensure we have a substantial amount on hand. Coal moves into the plant on a conveyor and is stored in a series of silos, each one leading to a feeder, pulverizer, and ultimately to the boiler. At Plant Miller, we have 4 generating units, and each unit has 7 silos feeding into one single boiler. The coal within each silo falls into a feeder, which measures and controls the flow of coal into a pulverizer. Inside the pulverizer, coal falls onto a large rotating bowl, where it is continuously crushed by 3 large grinding wheels until it becomes the consistency of baby powder. Once the coal is a fine powder, It falls off the grinding bowl and is carried by warm primary air, maintained at 140 degrees Fahrenheit inside the pulverizer, to the boiler through 8 burner lines. When the particles of coal reach the burners, they are mixed with secondary air that has been preheated to over 500 degrees to support complete combustion inside the boiler. The combustion of the coal converts its chemical energy into thermal energy, creating a temperature inside the boiler of over 2200 degrees. That's enough to heat the water in the series of boiler tubes to create steam, which moves onto the turbine to power the next step in our process. Superheated steam from the boiler, which is approximately 2400 psi and 1000 degrees, travels to the high-pressure section of the turbine, where it creates the force that turns the turbine shaft. This process causes the steam to lose temperature and pressure, so it must be sent back to the boiler to be reheated to 1000 degrees. After reheating, the steam returns to the intermediate turbine and continues through the crossover into the low-pressure turbines. The force of the steam turns the turbine shaft, which turns the generator rotor at 3600 revolutions per minute. This rotation, along with the induced current on the rotor inside the generator, produces voltage, completing the process of generating electricity. The generator output is 24,000 volts, which is stepped up to as much as 500,000 volts for transmission. Plant Miller uses a closed-loop circulating water system that allows water to be reused over and over. One way we use water is in the condenser, where steam enters from the turbine and condenses back into water as it passes over tubes filled with cool circulating water, which is chlorinated river water from nearby Mulberry Fork of the Warrior River. The condensed water moves into the hot well, where it re-enters the system to be reheated, turned back into steam, and continue its use throughout the plant. Let's take a closer look at the circulating water the plant uses, starting at the cooling tower. Cool water is pumped from the cooling tower basin through large pipes to the condenser to absorb most of the heat from the turbine exhaust steam, leaving us with warmer water that must be cooled. So, the warmer water is circulated back to the cooling tower, where it enters through riser lines to the top of the cooling tower fill. As the water cascades down the cooling tower fill material, it's air-cooled, allowing the heat to escape up through the natural draft cooling tower. The cooled water is collected in the cooling tower basin to be recirculated back to the plant to condense more turbine steam exhaust. Once combustion is complete, the heavier particles of ash, called bottom ash, fall into the bottom boiler. There, the bottom ash is crushed using clinker grinders, mixed with water and sluiced to the hydro bins. The water is decanted and ash collected in dump trucks and either sold or moved to on-site storage. While the heavier particles of ash fall to the bottom of the boiler, hot flue gas containing finer particles of fly ash naturally flows up to the top of the boiler and around, down, out through the backpass section. The last section of the boiler is the economizer. Because of the shape and the flue gas flow path, some of the fly ash falls out here into hoppers. This economizer ash is pulled by vacuum, mixed and sluiced with water to the ash booster station, where it moves to on-site storage. Flue gas, by combustion, exits the boiler and enters the catalytic converter, or SCR. While entering the SCR, ammonia is injected into the flue gas, where it reacts several layers to the nitrogen oxide compounds. The flue over 400 the exiting flue gas reheats the secondary the plant. Next, the flue gas passes through the precipitators. A negative charge is induced onto the fine particles of ash contained in the flue gas. That ash is then collected with an opposing charged collecting plate, shaken by vibrating rappers, causing ash to fall off into hoppers at the bottom of the precipitator. The ash is then pulled with a vacuum to a collection facility for sailor storage. The gas then passes through the induced back fans into the scrubber, where booster fans pull the flue gas from the plant and push it through the scrubber absorber. In the absorber, flue gas mixes with water and limestone. Stone reacts, removing 90% of sulfur dioxide, creating a byproduct of gypsum. The wet flue gas exits out the top of the absorber through to the wet stack, and a gypsum stream is pulled from the bottom of the absorber and sent to a watering facility. Inside the most of the moisture is removed from the gypsum so it can be sold for use in wallboard. Bolts to substations that handle the large voltage.
This is Drax, a coal-fired power plant in England. The size of 2 Manhattan Central Parks, side by side. This machine puts out almost 4,000 megawatts of power, enough to light up 5 million homes. And it does up to 36,000 tons and side by side. This machine puts out almost 4,000 megawatts of power, enough to light up 1 million homes. This new style coal burner has found a way to process and burn an old style fuel. And it does it so efficiently, it's now one of the cleanest mega coal plants in the world. Let's see how it works. Drax burns up to 36,000 tons of coal every day. That's 26 train loads. The trains dump the coal into giant hoppers. They slow down, but never stop. Every month, they dump enough coal to fill a 70,000-seat football stadium. But Drax doesn't burn chunks of rock. It's not explosive enough. So it converts the coal to dust. A network of conveyors sends the raw coal to these pulverizing mills. Each mill has 10 one-ton steel balls packed together on a track. Coal drops into the mill through here, and the ring of balls crush the rock. A single pulverizer makes 36 tons of coal dust in an hour, and Drax has 60 of them. The coal dust is now an explosive fuel, lit up by propane and oil burners. This coal, dust, and air mixture burns at over Celsius. Each boiler is a mega kettle with flames 5 stories high. 10 stories above the flames, inside a network of steel tubes, water transforms to high-pressure steam, hot enough to melt lead. Drax is now ready to generate some serious electricity. The steam heads to the turbine hall. The turbines are housed in 6 units, each the size of a locomotive. Inside, 5 steam turbines. Each spins a drive shaft connected to a generator. When the steam hits the turbines, its explosive pressure spins the blades at 3,000 RPM. The blade tips travel at 1.5 times the speed of sound, pumping out 1,000,000 horsepower. That's the same as 6,500 passenger cars. So, burn coal, boil water, make steam, and spin 300 tons of stainless steel at Mach 1.6 to create 23,000 volts of electricity. Voltage measures how quickly electrons flow through a wire. And Drax needs much more than 23,000 volts to get power to its millions of customers. The transformers at Drax take the 23,000 volts from the turbines and step it up to 400,000. Which is great for the national grid. But what about this stuff? Burning coal is dirty business. It belches out harmful gases that cause smoke and acid rain. Captures 90% of toxic emissions before they hit the atmosphere. Smoke goes into these electrostatic precipitators. Toxic particles cling to these metal plates like fridge magnets as the steam passes through. But filtered smoke still contains sulfur, the culprit net. So, before it's sent to the smokestack, it's cleaned again. Every week, 10,000 tons of limestone is crushed into powder and mixed with water to form a slurry in this giant blender. When smoke is pumped through the slurry, sulfur is chemically locked into it. The resulting combo makes 750,000 tons of gypsum every year. The stuff that makes drywall and plasterboard. 36,000 tons of coal burnt up in a day, covering most of its toxic emissions. This machine has always been powerful, but recent innovations have turned it into one of the cleanest plants of its size in the world. By propane and oil burners, this coal, dust, and air mixture burns at over 2,000 degrees Celsius. Each boiler is a mega kettle with flames 5 stories high. 10 stories above the flames, inside a network of steel tubes, water transforms to high-pressure steam, hot enough to melt lead. Drax is now ready to generate some serious electricity. The steam heads to the turbine hall, which is great for the national grid. But what about this stuff?
એની યુટિલિટી છે કારણ કે આપણા ગ્રાઉન્ડમાં તો હસ્તાક્ષરના કેબલ જતા હોય તો ફોરેનમાં શું છે કે બધું સિસ્ટમેટિક હોય એક મોટી તાર હોય એમાંથી જોઈ જોઈએ બરોબર આપણા ત્યાં તો હા એટલે આપણા ત્યાં તો વોરંટી ઉપર રિલાયન્સ ઉપર એરટેલ કેબલ હોય
See, this is one more video regarding the power generation. That is similar to the previous two also. You can see this is the overall layout of the thermal power plant. These are the three cooling towers, natural draft cooling towers. You can identify it with its height. First of all, this coal is coming over there, then it is supplied to the coal yard. From the coal yard, it is being picked and is sent to the pulverizer, as we have seen in earlier videos also, where it is getting pulverized. See, this is storing and pulverizing. It is being stored and pulverized, and then after it is sent to the boiler for the combustion. You have seen it earlier. That is, in this case, it is converted into the fine powder and it is mixed with the air. See, you can see how the pulverization process is taking place. Pulverization technique may differ, but ultimately you are converting this coal into the fine powder, right? For the say it is for the utilized for the further combustion and converted into the steam. See, you can see the mechanism. Okay. See, it is supplied with the air. You can see the number of say burners and the mechanism how the firing of the coal is taking place inside a boiler. See, basically it's a radiant heat transfer. Energy transfer is taking place with the help of the radiation. Right. Turbine generation that you are all aware with. So we are skipping this portion. See, we are moving to the condenser. You can say this is cooling water is coming out, the steam is passing across, and this cooling water is converted into the say somewhat hot water, and it is going to the cooling tower. And here the steam is getting condensed. So phase change is taking place. Again, this mechanism, this figure is familiar to you. The hot water is going on, and in the cooling tower, the water is spread from the top. That means atomization of the water is taking place, and air, due to the pressure difference, it is going up. So it will cool the water, right? And that cooled water is again utilized in the condenser for the condensation of the steam, which is coming out from the turbine, steam turbine. This is scrubbing technology. See, why these things are important. Say, you cannot, or you can say, you are not allowed to leave that hazardous particles in the air because they are environmental threats. To overcome this, you have to you can say cover maximum number of these hazardous particles, right? And you cannot allow them to escape in the air. So these are some techniques. Scrubbers are there. Mechanical is there. Then air filters are also there. ESP is also there, right? So these are some mechanisms for the reducing the pollution that is caused by the thermal power plant. They will come again in ash handling plants also, that mechanism. Say gypsum process, the byproduct is gypsum. Thermal power plants, byproduct is gypsum, that you will come to know later on. How the gypsum is prepared. Okay, that is none of our business, but byproduct is gypsum. See, again, this is one system which helps to prevent the pollution that is caused by the thermal power plants. That this topic will again covered in the forthcoming lectures. Electricity path, they are not very much interesting for us. Am I audible now?
Yes, sir.
Yes, sir. Yes, sir.
Bharat Chaudhary, you are the only student, or somebody else is also there?
Sir,
Yes,
Nirbhay Kumar,
sir.
Patel Nirbhay Kumar.
Patel Nirbhay.
हाँ.
I think that is old student.
Yes, sir. Yes, sir.
So why is not there? Patel Nirbhay. Patel Nirbhay is there. Yes.
Yes, sir.
16028011907.
6.
Patel Nirbhay.
Yes. Yes, sir.
Okay. Okay. So this was about the, say, general layout of the thermal power plant and how the path will be taken by the water and steam, then the air and flue gas, then cooling water, right? So now, what is the thing? I think we have already discussed that there are certain criteria for the selection of the thermal power plant, right? You know that this thermal power plant works on the Rankine cycle, right? So here, Rankine cycle, we all know, so we are not discussing right now the Rankine cycle, but you cannot establish the thermal power plant anywhere, wherever you like, right? There are certain areas that are required to be followed, or you can say you have to say there are certain conditions which should be there, or you can say which can create the favorable conditions for the establishment of any thermal power plant. First of all, that is the availability of the coal at the nearby places, right? So your thermal power plant should be established at the places where your coal should be available at the abundant quantity. Second thing, you can see that we require a large quantity of water for the steam generation. So again, second requirement is large quantity of water should be available. So they should be established near a large river, or you can say where the ample quantity of water should be available to us. Okay. So these are the two things, availability of the coal, availability of the water. Third thing, availability of the land, right? Because you can see from the layout itself, you can judge a large piece of land is required for the establishment of the any thermal power plant, right? So you require a large land, right? So basic three requirements: land, coal, and water, right? Fourth requirement, availability of the labor, right? Who will work there? Some labor should be there. So labor should be there. Availability of the skilled and unskilled personnel for them. Next thing, that is the availability of the transportation. you should be able to transport the things. See, you cannot construct this in one night. It will take years for the construction of any thermal power plant to be constructed. So construction will go for the years. So transportation should be available there, because you can see the number of things they are required to be transported at the site of the thermal power plant. Some have to make ready-made and supply there, but something, or you can say majority of things, they are required to be assembled at the site. So there should be availability of the transportation for the say quick movement of the say labor as well as the parts also, right? So it should be away from the your cities. You can see in the our you can say videos itself that you can see available you okay by there are certain issues related to the pollution, atmospheric pollution. So preferably you cannot establish your thermal power plant in, or you can say near to the cities, because there are some environmental, or you can say serious environmental threats, right? So you cannot establish a thermal power plant near to the cities. It your load center. What is load center? The electricity that you are generating. Load center, that means where it is consuming, where you are consuming the your electricity, that is your load center, right? One is generation center, that is your thermal power plant, and one is the load center where you are using, ultimately using your electricity. So it should be away from your say load center, or you can say sorry, it should be very near to your load center to reduce the transmission and distribution losses. Say it is contradictory, you can say. See, one thing what we are trying to establish a thermal power plant which is away from the city, and in second point it should be near to your load center, right? So that is contradictory, but these are the two criteria also there establish the power plant. Next is the quality of the land should be good, right? Otherwise, for the you can see this. There are number of large constructions are going to be there, and you require some strong foundations if the quality of the land is not proper, right? So that may add some additional cost to your that. Okay, so these are certain say criteria that are required to be fulfilled for the establishment of any thermal power plant, right? So this is one thing that we would like to discuss. Okay. Please be online. I am sharing something to you.
Hello.
I am online. You be online.
Yes, sir. Yes, sir. Yes, sir.
I am sharing right now the practical number 1 for your you just look at that, and I will share the say PDF of that on our say main say stream feeds, right? So you can just get it download from
Yes,
there.
sir.
Okay, and there are 2 or 3 say quiz problems are there that you can go through that. They are very basically they are easy problems. Okay, okay, cooling tower, superheater, reheater. Okay, so I am for reference. Okay. Is it visible? Okay.
Yes, sir. It is visible.
Yes. So this is your first practical. Basically, you can see this layout. See, this is pond. You are taking water from that and from the pump. This is feed water pump. Okay, this is ordinary pump, and this is the feed water pump that you are supplying to the boiler, right? Can you see this arrow that I am showing?
Yeah, yes, sir. Yes, sir.
Yes, it is going to the boiler, right? So from boiler, see that water is converted into the steam and it is passed to the turbine, right? From turbine to condenser. From it is converted condenser. Again, in condenser, it is converted to the water, and through this pump, it is again supplied. Okay, so this is the closed cycle for the water. Okay, for the closed cycle for this. Okay, water and say steam. Okay, now you can also see coal and ash handling. See, coal from the storage, it is supplied to the boiler where it is getting combusted, right? And it is converted into this now flue gas, and it is going to the chimney. And here, ash. Here, this is coal and ash circuit. It is converted into the ash, and one more system, that is the say ash ponds are there. That means you are collecting the ash and you are mixing with the water, and you are just you can say flowing it to the a special place which is known as the ash ponds, right? Where all these molten ashes and is getting collected, which can be used later on in making say bricks as well as the roads also. Okay, here this air circuit, that means you are absorbing the air, and here it is used post draft. It is supplied to the boiler, and it is mixed with the say products of the combustion, and it is combined now it is known as the flue gas, and it is passing through the chimney and exhausting in the atmosphere. Here cooling water circuit is there, say water hot steam which is coming out in the entering in the condenser, and water is just passing through. This is through the heat exchanger. This water is heated over there, and it is required to be cooled. So it is supplied over here and sprayed from the top, collected from the bottom, and again it's supplied to the condenser in a this way, right? And air is passing through over here. So during this process, there is some loss of water. So for the makeup water, we are using water from this river itself, right? So here some loss of water is taking place. So we can use it from this. Okay. So this was the general layout, and you can say this is Rankine cycle, major components, economizer, air preheater, boiler, that you can read. There is nothing special about this. You are familiar with this. Now these two quiz questions that you are supposed to write. Write in your file pages, right? Two quiz problems are the classify power plants. You can get it from any book of say power plant engineering, and the explain the shortly the site selection criteria for thermal power plant. Again, these two answers are available in a book of the any thermal power plant book, right? So you can perform that. Any doubts regarding this?
No, sir.
No, sir. We have no, sir.
બોલો વાંધો નહીં.
ફાઇલ પેજીસ જ નથી સર, એટલું છે.
ફાઇલ પેજીસ નથી.
હા,
કઈ વાંધો નહીં. આ ક્વિઝ ના ક્વેશ્ચન ક્વિઝ બહુ મોટી નથી, રાઈટ? આ દરેકમાં બે ત્રણ એવા તમને ક્વિઝ મળશે, રાઈટ? અચ્છા, તમે એલડી સિવાયના ફાઇલ પેજીસ વાપરી શકો છો.
એટલે બુકમાં લખે તો એવું ચાલે એવું છે. અત્યારે તો હાલ બુક જ છે અહીંયા.
બુક સિવાય કઈ નથી.
હા,
તમે સ્ટેશનરીની દુકાનમાંથી વ્હાઇટ પેજીસ ફાઇલ પેજીસ આવે છે, યુ કેન બાય ધેટ.
ઓકે ઓકે.
સ્ટેશનરી દુકાનમાંથી ફાઇલ પેજીસ લઈ લેજો એમ, અને વ્હાઇટ પેજીસ લેજો.
હા સર.
બરાબર. અને જો તમારે, કેમ કે આમાં શું છે કે આ જે ક્વિઝ છે એ તમારે તમારા આ જે પ્રિન્ટ આઉટ તમે કઢાવશો એની પાછળ તમારે એટેચ કરવાની છે, રાઈટ? આ ક્વિઝ છે એ કઈ રીતે જુઓ થશે કે ભાઈ આનું પ્રિન્ટ આઉટ પાછળ આની ક્વિઝ આવશે એમ. એટલે એ રીતે હું કહું છું કે તમારે A4 સાઇઝ ના પેજ હોવા જોઈએ એમ.
હા, બરોબર.
અથવા તમે એક કામ કરી શકો છો કે ભાઈ A4 સાઇઝ ના બ્લેન્ક પેપર હોય, રાઈટ, એમાં પણ લખી શકો છો, બટ ઇટ શુડ બી ઓફ A4 સાઇઝ કે જેથી તમે એ કરી શકો એમાં સાઇઝમાં બહુ પ્લસ માઇનસ ના થાય બાઇન્ડિંગમાં. નહીતર શું થશે કે બાઇન્ડિંગ જે થયા પછી તમારે ફાઇનલ વાયવા વખતે તમે જ્યારે ફાઇલ લઈને આવશો તો ઇટ વિલ લુક ઓડ. એવું ના થવું જોઈએ, એટલા માટે દેટ ઇઝ માય ક્રાઇટેરિયા કન્સર્ન કે ભાઈ તમે ગમે એમાં લખો પણ એ વ્યવસ્થિત થવું જોઈએ એમ. એટલા માટે હું હંમેશા ફાઇલ પેજમાં લખવાનો આગ્રહ રાખું છું.
અત્યારે સર નથી એટલે મેં કીધું, બાકી તો એમ તો ફાઇલ પેજમાં લખીએ છે, અત્યારે છે
ક્યાં રહો
નથી
છો?
એટલે. અત્યારે અમે ગામ છે સર, અત્યારે તો એવું છે.
હે?
અત્યારે ગામ રહીએ છે નવસારી.
તો નવસારીમાં સ્ટેશનરી દુકાન નથી?
એટલે અમે સર ગામ છે, અત્યારે ગામમાં
એવું છે એમ?
જવું પડશે. હા
વાંધો નહીં, જ્યારે શહેરમાં ચક્કર તો મારશો કે નહીં મારો શનિ રવિમાં?
અત્યારે તો અહીંયા હા શનિ રવિ મારીએ એમ તો, બાકી બહાર જ
અત્યારે
અત્યારે છું.
સ્ટેશનરી દુકાનમાંથી મળે તો લઈ લેજો. અત્યારે આર્ડેન પાસ ક્યાં છે ક્વિઝ સબમિટ કરવાની?
ઓકે ઓકે
ક્વિઝ તો તમારે એન્ડ ઓફ ધી સેમેસ્ટર સબમિટ કરવાની છે, અત્યારે નથી કરવાની, બરાબર?
હા સર હા સર.
હા વાંધો
તો
નહીં.
વાંધો નહીં.
હા એટલે એવું નથી કે ભાઈ તમે, હું તમને એવું નહીં કહું કે ભાઈ તમે આવતા સોમવારે કે મંગળવારે એ તમારું જે ક્વિઝ છે અપલોડ કરી આપો એમ, બરાબર?
હા
એવું નથી. હા
તો
તો
વાંધો
ડોન્ટ
નહીં
વરી.
આરામ.
હા એટલે તમારી પાસે ટાઈમ છે, 15 દિવસ પછી સબમિટ કરશો તોય ચાલશે, બરાબર?
ઓકે સર ઓકે.
હા. So this was our first practical, that is the general layout of the modern steam power plants. Okay. So હું આ જે વસ્તુ છે PDF માં તમારા આપણે જે મેઇન જે છે એમાં શેર કરીશ ફીડમાં, ત્યાંથી તમે ડાઉનલોડ
હા
કરી લેજો, બરાબર? છેલ્લે તમારે આને બાઇન્ડ કરાવવી પડશે એટલા માટે, બરાબર?
ઓકે સર.
Okay. So our meeting ends over here.
ઓકે.
Right? So you can leave the
Okay, sir.
meeting.
થેન્ક યુ સર.
Welcome.